this video, I'm going to look at some higher order derivatives, specifically the second derivative. So basically, for some problem like this or a problem like this, you have to find the first derivative using implicit differentiation. So one thing that you should note is that that's really just y to the 1/2 plus 2xy equals to 4. And I actually got this problem from one of your classmates, so it's this one right here. Um, so we need to find the first derivative. Now, this definitely is a challenge, to be honest. So we have 1/2 y to the negative 3/2 multiplied by, actually it's not 3/2, is it? It's negative 1/2, sorry. That should be negative 1/2 times y prime. Now I'm just going to use a y prime because I'm going to get tired of writing dy dx repeatedly. So plus 2 times y plus 2x times y prime equals to 0. Now the main thing that I'm going to take note of is that if I rewrite this equation, I have y prime divided by 2, the square root of y, plus, I'm going to put the 2x over here, so 2x times y prime, and then plus 2y equals to 0. Now, if you actually go ahead and do some multiplying by, let's say, like 2, like for example, like we multiply by 2 y prime, not 2 y prime, I'm sorry, 2 square root of y. So let's do that. So if we do that, then we end up with y prime plus, okay, so this is where it gets kind of interesting. You have 2 times 2 is 4, so that's going to be plus 4x, and then you have the square root of y multiplied by y prime. And then you have plus 4. Now, y to the 1/2 plus y to the 1 is y to the 3/2. So you have y to the 3/2 equals to 0. Now from here, if you solve for y prime, basically you're going to find that y prime from this equation is negative 4y to the 3/2, all divided by 1 plus 4x, and then you have y to the 1/2 right there. Okay, so the next thing that you'll need to do is to apply the quotient rule. So basically, quotient rule says that if you have a function like f divided by g, that if you take the derivative of that, that's going to be g times f prime minus g prime times f, and then that's all divided by the denominator squared. So essentially we have to do that with this function through y dx. So it's definitely going to get a little messy. So you have 1 plus 4x root y multiplied by the derivative of negative 4 times y to the 3/2. So that's going to be multiplied by negative 4 times 3/2 y to the 3/2 minus 1, which actually is just going to be 1/2, okay? And then from there, you have that this is going to be minus. So from here, you have that you're going to take the derivative of the denominator. So the derivative of the denominator is 4 root y. And then you have that you're going to have plus 4x multiplied by the derivative of the square root of y. So the square root of y we already have is just 1 divided by 2 root y, but you got to tag on a y prime to it. But then you also have that that's going to be let's see. That's also going to be that it's going to be the times the original, that like in terms of like negative 4 y to the 3 halves. So from there, I wouldn't recommend distributing too much right now. So right now, and let me just be okay, there's a y prime missing right there. So that's times y prime. There's a y prime right here missing. Yeah, and we can actually just, scroll back up if we're not too sure, which I always need to check to see that I didn't miss anything. So negative that, so then denominator squared, and it's going to be the numerator times the derivative of the denominator times the derivative of the numerator, which is going to be, right, negative 4 times that, so that's 3 halves, then take away the 1, so that's going to be just a half, but then times y prime, which that's what I forgot. Now, from here, we're multiplying by the we're multiplying by the derivative of the denominator, which in this case is going to be just using product rule, 4 root y plus 4x, and then there's where you have that right there. Multiplied by the numerator. Okay, so it looks like everything's good in terms of this. So like we're just going to take everything and divide it by the denominator, 4x root y, and that's going to be squared. Now, unfortunately, like as I go ahead and I reduce a little bit more, you're going to note that basically there's not really too much that's going to happen on the initial simplification. So we have 1 plus 4x root y, and then you have, that's going to be negative 6 times negative 6 y to the 1 half minus, now it's up to you on like if you want to reduce or not and distribute if you want to. Like for example, I could probably just say plus 4 y to the 3 halves, and then multiply by the 4 root y. And then over here you have plus 2x divided by the square root of y. And then you tag on the y prime. Okay, so there's just a little bit to do in that regard. um, let's see. Okay, so, oh, and I keep forgetting that y prime. Okay, so that's going to be all divided by the denominator squared still. Okay, so what is that, like 1 plus 4x, and then you have the square root of y, and then that's squared. Okay, so from here, it looks that we can still sort of combine like terms if we want to. Let's see. Yeah, it's probably going to be best that I go ahead and I keep distributing as much as possible. So like for example, I'm going to put this over here, the negative 6 y to the 1 half multiplied by 1 plus 4x square root of y. And then we have plus, okay, so this is where I'm going to go ahead and start distributing. So I'm going to have 16 y squared. And then from here, I'm going to have 8 plus 8x. Now, when I distribute this right here, the y to the 3 halves, I'm taking away a half from it. So that actually should just be xy, 8xy. But Oh, and I keep forgetting that y prime over here. Y prime. And then there's another y prime right there. Okay. Now all of this is divided by all of this is divided by the denominator squared. So we have 1 plus 4x times the square root of y, and that's going to be squared. Now from there, this is where, we're going to kind of just substitute as much as possible. So with that, we're going to substitute the y prime. Now notice that the y prime will actually cancel out a few things, so that's going to be good. Okay, now this gives us negative 6y to the 1/2 multiplied by 1 plus 4x. Yeah, 1 plus 4x root y multiplied by the derivative, which is negative 4y to the 3/2. And this is divided by that denominator, the denominator 1 plus 4x root y, of which you can see that basically that cancels out. But let's, not get too ahead of ourselves. Plus 16y squared plus 8xy, but multiplied again by the derivative. Okay, so multiplied by the derivative, you have that's going to be negative 4y to the 3/2, and this is all divided by the 4x square root of y plus 1. Now, you'll see that basically that doesn't cancel out at all. In fact, if you multiply even further, you'll see that you're going to end up with 5/2 with one of the variables. So, and all of this again is divided by 1 plus 4x, the square root of y, and all of that squared. So eventually the goal is going to be to essentially just multiply by the denominator until we can get it down to an easier or a much nicer looking implicit derivative. But I might not just simplify it entirely. So we have 24y squared. Yeah, 24y squared, and then we have plus 16y squared. So luckily these two are going to combine, definitely combine like terms. But remember that we're still going to have to multiply by the denominator at some point. So the rest of this is going to be negative 32x, and then let's see, 1/2. No, wait. That's 1, right? So that's going to be 1. So that's going to be 5/2. So that's going to be y to the 5/2, and all of this is divided by 4x, the square root of y plus 1. Now, remember that essentially you're still dividing by that denominator that I keep repeating. So here you have that's going to be okay, so here the denominator again, okay, so let me just clean that up. Okay, so here we have 4x, the square root of y. Let's do that a little, plus 1, and then we square it. So basically, you have 40y squared. Okay, so you have 40y squared minus 32x, and that's going to be y to the 5 halves, and all of this is divided by 4x root y plus 1. Okay. Now remember that you're still dividing by the denominator that I keep repeating. Now, if you want to keep track of it, you can, like in that regard, like just put a placeholder. Uh, like if you want to put like a little smiley face or something. Like, okay. So from here, it's all just a matter of multiplication. So you have that when you multiply this through, you have that you're going to have 160. So this is going to give you, well, let me do it like this. I'm going to actually just say that we're going to have 40y squared multiplied by 4x root y plus 1, and then minus 32x, 32x to the y 5 halves. And all of this is going to be divided by the denominator squared, cubed actually. So 4x root y plus 1, and then we're just going to cube that. Let's just pause. So if we simplify this, basically you'll get that, you know, uh, so basically what you'll get is that this is going to be 5 halves, so that's going to be the same thing right there. So that's going to be like 128. So you have like 128 x, and then you have y to the 5 halves, and then you have plus 40 y squared, and all of this is divided by 4x square root of y plus 1, and then that's going to be cubed. Okay, now there actually is a textbook question where like the equation looks something like this. The square root of y plus xy equals to 1, and they ask you to find the second derivative with respect to x. And actually, the second derivative, so this one actually worked out already, and I found that the solution for the second derivative of this equation, so definitely, like, we might not be sure, but if you just go back, you'll probably it should check out. But if there was a mistake, then you'll probably find it somewhere. And if that's that, like that does happen every now and then where you might make a mistake. But definitely the first derivative is okay. So the solution that I got for this one was using implicit differentiation was 2x uh, times y, root y, plus 1, and this is going to be raised to the third power. Now, the top part actually came out to 10, so it came out to 10 y squared, and then I have plus 16 x times y to the 5 halves. So for sure, this one I did work out earlier from the textbook, and when I looked at your classmate's question, it was very similar, but like the numbers are obviously like just a little bit bigger. And then this one, I, every time I do a problem, I don't really do it the same way twice almost, because I kind of see that I can do like a little shortcut. So back over here, where I decided not to FOIL, that was my own decision to do that because I didn't think that it would be useful to distribute and then uh, you know plug in y prime, and then it's like, okay, I think stuff does cancel out. But yeah, anyways. Okay, so definitely these are challenging problems, and You're not really going to have any that resemble this necessarily. They're more accessible, like, ellipses, circles, reciprocal functions. So yeah, definitely do practice this, but try not to spend too much time, because more or less it's just a test of, algebra and all that kind of stuff.